Hello guys, welcome back to our channel. I am Yugandhar working as an embedded software engineer. And today in this video we are going to know about Serial Peripheral Interface Protocol. If you are new to this channel, please do subscribe and like the video. Without wasting any time, let's go into the video. Hello guys, today we are going to discuss about SPI, Serial Peripheral Interface. By the end of this video, you will be learning completely about SPI and where we will use this SPI in real world embedded systems. And watch till the end of the video, you will get complete knowledge about SPI. Before learning SPI, you need to know about what communication protocols are. As we humans talk to each other and communicate in the similar way, embedded systems also need to transfer data each other to establish communication between them. So, communication protocols are used for that. Few communication protocols are SPI, I2C, UART, CAN, etc. And today we are going to discuss about SPI. SPI is a synchronized serial communication protocol. It is used to communicate with one master and multiple slaves. One master can communicate with one or more slaves. While communication, there are 4 lines: serial clock, MOSI, MISO and chip select. These 4 lines are used between the master and slave to establish communication between them. Here, serial clock MOSI is master output and slave input. MISO is master input and slave output. Here, MOSI will send the data. This line is used to send data from master to slave. That is what master output and slave input. And this line is used to collect the data from slave to master. Master input and slave output in this direction. And chip select is used to select the slave address. Based on this, master can decide to which slave it should transfer the data. And this SPI is a full duplex communication protocol, means the data between master and slave can be established simultaneously. They can send each other data simultaneously. This SPI is faster and it is used in short distance. For example, in a microcontroller, when CPU need to communicate with sensor, EEPROM, SD cards, display or something, then this protocol is used so that it is faster and it is short distance. Based upon the requirements, we need to choose our protocol. And I2C is bit slower than SPI and it is used for little long distance. And here slave is get activated only when slave select pin is pulled to ground. And we are having 4 pins, right? And it is not mandatory to configure all 4 pins. It can be configurable based on the requirement. If slave doesn't send the data, means the slave doesn't need to send the data to master, then 2 lines is enough. Is MOSI and slave select and clock is enough. SPI communication is based on shift registers. Means there is a one shift register in master and one shift register in slave. Now the data is in master and need to be sent to slave. Here we have 4 pins. This is clock, this is MOSI, master output and slave input, and this is MISO, master input and slave output. So for each clock cycle, 1 bit of data will be transferred to slave via MOSI, master output and slave input. Similarly, when this bit is transferred here, this data will be shifted by 1 bit, and the last bit of data again comes to the master and stores here. This cycle will happen until all these 8 bytes of data will be transferred to the slave. In this way, the communication will happen between master and slave. And SPI is a full duplex communication by default, means the master and slave can communicate simultaneously. And according to your requirements, you can also make it half duplex by connecting MOSI pin of the master to MISO pin of the slave with the register between them. And we are going to discuss about SPI communication format. In SPI, there are 3 communication formats. One is clock phase, clock polarity and data frame format. As we discussed before, during SPI communication, receive and transmit operations are performed simultaneously. The serial clock synchronizes the shifting and sampling of the information on the data lines. Clock will play a major role in this SPI communication. The communication format depends on clock phase, clock polarity and data frame format. to be able to communicate together, master and slave devices must follow the same communication format. Now we will explore what exactly the clock phase and clock polarity is. First we will discuss about clock polarity. Clock polarity is nothing but the clock polarity bit controls the ideal state value of the clock when no data is being transferred. Means when no data is transferred, then clock polarity bit controls the ideal state of the clock. If clock polarity is reset, then the clock pin has low level ideal state. If the clock polarity is set, then we have high level of the ideal state. Wait a minute, I will draw for you. Here you can see, right, this is the clock. When clock polarity is 0, means the clock starts from 0 and it will rise to high, and at last when it ends, it will end with 0, means at low state. Similarly, when clock polarity is 1, the initial state of the clock is high and it goes to low, and at the end of the clock, again the clock will ends with the high state. This is what clock polarity is. And clock phase. Clock phase controls at what edge of the clock the data should be sampled. Means at the rising edge or the falling edge, at what data should be sampled. The combination of clock polarity and clock phase bits selects the capture clock edge, means where the master and slave captures the data. Wait a second, I will draw one more diagram for you. This is when clock phase is 1. When clock phase is 1, data will be appeared on the lines during the first edge of the clock, means here. Here the data will be appeared at the first edge of the clock. When clock phase is 1, the data will be appeared at first edge of the clock, means the master and slave will capture data at the second edge, means here. As before we have discussed that about clock polarity. When clock polarity is 1, the starting edge of the clock is high, and when clock polarity is 0, clock starts at the low stage. When clock phase is 1, the data will be appeared here and sampled by here. Here is the MOSI pin. Here MOSI, which is the transmitter which transfers the data to slave, and this is the receiver edge, which is MISO, which gets the data from the slave. And this is NSS pin, which select the slave. If you need to know in a simple way, if clock polarity is 1, the data is captured in rising edge, and if clock polarity is 0, the data is captured at falling edge. In a similar way, when clock phase is 0, this is the default scenario, the data is appeared on the lines during the second edge of the clock, means here data will be appeared here, and data will be captured at the first edge of the clock, means the slave and master will capture at the first edge of the clock. And these are all you need to select based on your application requirements. And based on these clock phase and clock polarity, there are 4 modes of SPI. The 4 modes of SPI are mode 0, mode 1, mode 2 and mode 3. When the clock polarity and clock phase is 0, 0, the mode is 0. And when clock polarity is 0 and clock phase is 1, the SPI acts in first mode. When the clock polarity is 1 and clock phase is 0, the SPI is in second mode. And when clock polarity is 1 and clock phase also is 1, then SPI falls under third mode. If you want to remember everything in 2 sentences, you remember like this. If clock phase is 1, data will be sampled at the trailing edge of the clock, means at the second edge. When clock phase is 0, data will be sampled on the leading edge of the clock, means 1. And this is the end of the video. If you didn't subscribe yet, please subscribe to the channel and share it to your friends. And follow for more such content. Please do subscribe. And let me know if you have any doubts in the comment section.